Hello to all my viewers. This is Dr. Dhaval Maheta. And today we will understand how to plot the leaf chart in Neo-Bayes algorithm in KNIME. So Neo-Bayes is a popular machine learning algorithm used for classification tasks. It is based on Bayes' theorem and makes an assumption that the features used for classification are conditionally independent, which means that the presence or absence of one feature does not affect the presence or absence of any other feature. In practice, NewBias is commonly used for text classification, spam detection, and other similar tasks where the assumption of conditional independence of features may hold reasonably well. This assumption allows the algorithm to be computationally efficient and works well on large dataset. We can build new bias classification where we have dataset of emails labeled as spam or ham, which can automatically classify incoming emails as spam or ham. After running the algorithm, it is necessary that we test its accuracy. So for this, the confusion matrix is generated. Now, how to interpret this confusion matrix? Let's try to understand. Here, we are having a normal data set. That is, a person is having a COVID or a person is normal. We are having a data set where a person is having a COVID or is normal. And we are using the kit to classify that a person is having a COVID or not. So if a person is having a COVID and the kit also detected that yes, the person is having a COVID, so this is a correctly classified cases. Similarly, if the person is normal and the COVID kit detected that the person is normal, so 114 plus 50, 164 are such cases which have been correctly classified by the kit. The person is normal, but the COVID kit detected that the person is not normal. So is having infected with the COVID. So 6 are such cases which have been misclassified. Similarly, a person is having the COVID and the kit detected the person is not having the COVID. So 22 plus 6, they are misclassified cases. So 50 plus 114, we want more and more such cases which have been correctly classified. A lift chart, also known as a gain chart, is a visualization tool used to evaluate the performance of binary classification model such as decision tree, logistic regression, neo bias. The chart compares the predicted probability of the positive class against the actual proportion of the positive instances in the dataset. Lift measures how our model is performing prediction against the prediction without the model. Say, for example, we are having 10,000 cases. This will be divided into 10 parts. Each part will have will be assigned a 10 percentage probability 10, 10, 10, 10. Now, in this 1,000, the number of responses which we got in the first part is 876. In second part, 743. So the cumulative is 876 plus 743 is 1619. The percentage of the events which have occurred in the first part is 876 divided by 385, 83859, the total. So that is 22.70 percentage. The total baseline probability has been divided into 10 parts, so each part consists of 10% probability. The first part, even in the absence of the model, has 10% probability of any event to happen. It is a ratio of gain percentage to the random expectation percentage at a given decile level. Now, how to interpret this lift chart? In the first part, out of 1000 observations, the number of events that have occurred are 876, which is 22.7% of total events. So 876 divided by 3859. The gain for the first part is 22.70 percentage divided by 10 percentage. That is without the model. So we got 2.27%. This is the lift, 2.27, the lift, cumulative lift. The gain for the second part is 22.7 percentage plus 19.25. So it is 41.95. The cumulative lift for the first part is 2.27 and for the second part it is 2.098. So it is a 41.95 divided by 41.95 divided by 20 because 10 for the first and 20 for the second part. Now how we can generate the lift chart? Let's see in KNIME. So first of all, I will activate the input output node from here. Browse. Connect Heart1. Press open. Click OK. Now right click on it and execute. Again right click on it and see the file table. So we are having here the data set which consists of age, resting blood pressure, cholesterol, maximum hours of exercise, and the heart disease, yes and no. We'll activate the column filter from here so that we can include only those variables which are our matter of interest. Column filter, right click on it, configure, remove, take all the variables they said, only include the variables on which the model has to be created. Age, resting blood pressure, cholesterol, uh, maximum hours of exercise, and heart disease. Click OK, right click on it and execute. Again right click on it and see the filter table. Now let's activate the partitioning. We want to do the partitioning of the data set. Right click on it and configure. Make this as 80%. Activate this stratified sampling. Click OK. Right click on it and execute. Again right click on it and see the first partition. This consists of 80% of the data which will be used for the training purpose. Click on the second partition, this is the second partition. This data set will be used for the testing purpose. Now activate the new bias learner from here. Right click on it, configure, keep the default settings, click OK, right click on it and execute. Again right click on it and see the new bias learner. You will never get any equation or model, just like the regression or logistic regression in case of new bias learner. Activate the predictor from here, new bias predictor, that on the basis of new bias learner. Connect this to this, right click on it and configure. Double click on it, click OK, right click on it and execute. Again, right click on it and see the classified data. So this is the prediction done according to the model, naive Bayes model. And this is your original data set. Now we want to see how well our data set or how well our model fits to the data. So for this, we will activate the scorer from here. Right click on it and configure. Activate the hard disease from here, the original data, which we want to check against the predicted data. Click OK. Right click on it and execute. Again, right click on it and you can see the confusion matrix from here. So 62 are such cases in which the person was not having the heart disease and the algorithm also classified it correctly, yet that the person is not having the heart disease. 73 are such cases in which the person was having a heart disease and the algorithm also predicted it correctly. So 62 plus 73, 135 are correctly classified cases. The classification accuracy is only 73%. So you can say it's very moderate. 29 are such cases in which the person was having the heart disease and the algorithm predicted no, the person is not having the heart disease. So this is a misclassification which has been done. Similarly, if we talk about this part, a person is not having the heart disease and the algorithm predicted that the person is having a heart disease. So 49 are such wrongly classified cases. Now let's generate the lift chart. So this lift chart, you will have to connect it with the new bias predictor, configure, make sure uh, heart disease is on, right click on it, configure, heart disease, here heart disease, yes, this should be also yes. Make sure that this tick is there, create image at port, click OK, right click on it and execute. Again, right click on it and see the image. So you can see that for the first 10%, the first part, the lift is 1.7. Then for the next 20, the lift is the red line color, that is 1 point somewhere around 1.35. So lift goes on decreasing. So you can see for this observation, our lift is very less, which means that for this observations, the model is not working or rather after 60 or 65 percentage, our model is not working properly because the lift is less than 1. The cumulative lift is in the blue line. You can also generate the cumulative gain. Right click on it and configure and show the cumulative gain. Click OK. Okay. Right click on it and execute. Again right click on it and see the image. So this is the cumulative gain which you have got. So this is how you can generate the lift chart in KNIME. For more videos on KNIME, kindly subscribe to my channel. You can follow me on LinkedIn and Twitter. Please refer my playlist in which I already uploaded many videos on KNIME.